Alright, in this video we're going to be finding the slope. We learned last year that the slope can be written several ways. One way is y2 minus y1 over x2 minus x1. This is called the change in y over the change in x. We tended to call it something different. Up, right? When you're looking at a graph, when you go like this, you can count how many spaces up and how many spaces right, and create a fraction 3/2. We also talked about it when doing it in this form. You don't have the graph, so you can't do upright, but you can organize it. If you notice, it says y over x, so we're going to do our y's over our x's, and we can do it back y minus front y over back x minus front x. We could also organize it front y minus back y over front x minus back x. And we did that example last year and saw how it doesn't matter which y goes in front, but it does matter that you keep it consistent. So here we're going to start with our back y minus our front y, 3 minus 4, and our back x minus our front x, 6 minus 8. 3 minus 4 is -1. 6 minus 8 is -2. We can talk about it -1/2 over -1 over -2, and -1 over -2 is a +1 over a +2. Two negatives make a positive. If we had done it in the reverse order, we would have had to still take our y and do our front y minus our back y. 4 minus 3. 4 minus 3 is 1. And our front x, 8 minus 6 is 2. 8 minus 6 is 2. That's that same principle that if you do it back minus front, you might get a double negative and it becomes a positive, or you might get a positive, and if you do it the other way, you'll get a double negative, which again becomes a positive. So either way works. Here we're going to have back y minus front y. 2 minus 7, that's going to become a -5. And then our back x minus our front x, 9 minus 4. 9 minus 4 is 5. Is this fraction as simple as it can be? No, we can reduce it further. 5 divided by 5 is 1, so we have -1. That's our slope. You could have also written it as -1 over 1. Now we have 2 comma -4 and 5 comma 3 as our points. We're going to again do back y minus front y over back x minus front x. Our y's are 3 and -4. Notice when I write 3 minus, I can't write 3 minus 4. I have to write 3 minus -4. So we're going to need a parentheses there. Then our x is 5 minus 2. 5 minus 2 is 3. And 3 minus a -4, we talked about double negatives make a positive. Minusing a negative, subtracting a negative is also a positive. So 3 plus 4 is 7. This slope is 7/3. Now we have 3 more examples. 9 minus 3, 6. 8 minus 6, 2. So 9 minus 3, 8 minus 6. Is this fraction as simple as we can make it? No, we can divide both of these by 2, and we get 6/2 becomes 3 over 1. Is 3 over 1 as simple as we can write it? No, we can write it as the integer 3. So this is a slope of 3. Here we have 6 minus 5 is 1. This goes on the top because it's our y's. And -2 minus 5. So we can put a little parentheses around that -2. This was 6 minus 5 on the top. -2 minus 5 is a loss of 2 and a loss of 5, so that's -7. So this slope is 1/7. Finally, we have -1 minus 7. -1 minus 7. Again, we've lost a lot there. We've lost 8 total. And 5 minus 1 for our x's. 5 minus 1 is 4. Is this as simple as we can get it? No, we can divide both of these by 4 reduce it to get negative 2 over 1. Is that as simple as it comes? No, you can make it the integer negative 2. And I'll circle that slope. So that's how you do it when it's 2 points. Now we have the graphs. So on the graphs, one important point is to look for the perfect points on the graph. So not everything's a perfect point. For instance, this is floating in the middle. It's not on the integers. It's not on the intersections of the grid. So we need to ignore that point and look for better points. Here we have 2 perfect points clearly marked, and we're going to use our upright to solve for it. Upright, we go 1, 2, 3, 4 up, and 1, 2, 3, 4, 5 right. Remember to count spaces, not lines. If you count lines, you're going to count 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6. That's not correct. And that's saying that you went 1, but you didn't move at all. So we need to count spaces. I've moved 1. Now I've moved 2, 3, 4. So that is a 4/5. Here, look, this isn't a perfect point. So I say this is a perfect point, and then I examine it, and here's a perfect point. Now I can begin counting. Up 1, 2, 3, 4. That's a 4. Right 1, 2. Right 2. 4 halves. Is that as simple as I can get it? No, I can divide them both by 2, and I get 2 over 1. When this happens, you should test it and see that this new slope also works. I go up 2, and I go right 1, and look, there's another perfect point. So this is a slope of 2. Here, I need some perfect points. I see one here. I see one here. Someone else might have said, this is a perfect point. If I'm traveling down 1, 2, 3, 4. That's a negative 4 in the upward direction, in the vertical direction. And here I'm traveling right 2. Is this as simple as I can get it? No, I can simplify that to negative 2 over 1, which simplifies to a slope of negative 2. Let's test that to make sure this is correct. If I go down 2, I do go over 1 to get to the next point. Down 2. Down 2. So negative 2 is the correct slope. Ooh, here, very flat slope. It's going to be a very small fraction. I go up 1, and I go right 1, 2, 3, 4, 5, 6. Is this as simple as it gets? Yes, I can't simplify it any further, so the slope is 1/6. Here, it's tough to find some perfect points, but there is one. And here's another one, and let's travel. 1, 2 to the right, that would be in the denominator. And up, 1, 2, 3, 4, 5, 6. And since I almost mixed those up, let's write upright to make sure. Yes, right 2, up 6. Can I simplify this? Yes, I can. It becomes 3. And if I look, I can go right 1 and up 3. Traveling up 3, up 3. I could even continue this up 3. All right, this one, final problem. I'm going down. That's a negative. 1, 2, 3, 4, 5, 6. Down 6. And right 1, 2, 3, 4, 5, 6, 7, 8. Negative 6/8. Is that as simple as I can get it? No, I can divide by 2. I get a negative 3/4. Let's test it. Down 1, 2, 3, and right 1, 2, 3, 4. Ah, perfect. So this slope is negative 3/4. Remember, it's back y minus front y over back x minus front x. Happy times finding slopes.